Alright, so we're going to talk about the area of rhombuses and kites today. They kind of share a formula here. And so your learning target is I can find the area of rhombuses and kites. Alright, so the area of rhombuses and kites, we use the formula, and I'm going to go ahead and write this one down for you. It's the area is equal to 1/2 times D1 times D2. Okay? D1 and D2 stand for D1 is one of the diagonals in a rhombus or a kite, and D2 is the other diagonal in a rhombus and a kite. Okay? So this first example, it says a rhombus has a side length of 4 centimeters and a height of 3 centimeters. And we want to know what the area of that rhombus is. Okay, so first things first, whenever we're given kind of a word problem, it's a really good idea to draw things out so that we can kind of take a look at it a little bit easier, right? And remember, I'm a terrible drawer, but I'm gonna do my best. Okay, so we know that the rhombus has a side length of 4 centimeters, and if we have a rhombus, we know that every single side length is going to be 4 centimeters, right? Because a rhombus has 4 congruent sides. And then it says that it has a height of 3 centimeters. Okay, so we have to build in a height here. That's not the other side length, that's the height. Okay, now I just told you that the area formula for a rhombus and a kite needs the diagonals, right? 1/2 times the diagonal of one times the diagonal of the other. And here's the thing, I just gave you this and we don't know a diagonal at all. We don't know any of the diagonals. But here's the thing, this is a rhombus, and because a rhombus is a parallelogram, we can use that same formula to figure out the area of a rhombus. Okay, so the rhombus is kind of a nice little thing. It has a couple of different area formulas that we could use. Remember, way back when we said that the area of a parallelogram was base times height. Okay, that's going to hold true to a rhombus because a rhombus is a parallelogram, right? So therefore, the area of this figure is just 4 times 3, which means that the area of this is going to be 12 centimeters squared. Okay, that's the area of this rhombus. So we can use that formula as well. Okay, so now example 2, we're using that same problem that we just did in example 1. It says assuming the same rhombus has one diagonal of 8 centimeters. Okay, so we're looking at that same rhombus. I'll go ahead and redraw it super fast here. We've got 4 centimeters was the bases, and it tells us that one of the diagonals is 8 centimeters. It's asking what is the length of that other diagonal. Okay, so this is where we can use that formula we just talked about. 1/2 times the diagonal of 1 times the diagonal of 2, right? 1/2 times the diagonal of 1 times the diagonal of 2. Now I already told you, we already figured out what the area of this was. We said that that was 12 centimeters squared, right? So 12 is going to equal 1/2 times the first diagonal, which we found out was 8, times the second diagonal. I'm just going to call that D. And now all we have to do is just solve for D, okay? So 1/2 times 8, let's kind of simplify things a little bit first. 1/2 times 8 is 4D, and then divide by 4 on both sides. We end up getting 3 is equal to the other diagonal. The other diagonal. And it's 3, I'm sorry, we should write this again. 3 centimeters is the other diagonal. Alright, now example 3 is dealing with a kite, and it's the same exact formula that we have the area is equal to 1/2 times the first diagonal times the second diagonal. Okay, now so here's what we do know about this kite here. We know that this first diagonal, this long diagonal, is 17 feet. 17 feet, that's what it says right here. Okay, so we could start filling out this formula here. We're trying to figure out what the area is equal to 1/2 times 17, and now we need to know what is this second diagonal. What is the length of this horizontal diagonal? Now we're given a couple pieces of information here. We're given that the length from the diagonal's intersection point all the way down is 10 feet. Okay, so the whole length is 7 feet. The length of this one is 10 feet. Now what we know about a kite is that this it's symmetrical, so this length is going to be the exact same as this length. Okay, so get this. This is where this comes into handy here. Okay, if this is going to be 10, if one of this diagonal, this part of the diagonal is going to be 10 feet, and the hypotenuse of all of this is 13 feet, we can figure out what this missing length is right here just using Pythagorean theorem. We can figure out what this is using Pythagorean theorem, because a squared plus b squared is going to give you your hypotenuse squared, right? So let's go ahead and do that. We've got 10 squared plus our x squared, that's what we're trying to figure out, is going to be equal to 13 squared. And 10 squared is 100. 13 squared, you know what, I'm not too good on that, so 13 squared is 169 if we use our friend. Okay, then we subtract 100 from both sides, and we end up getting x squared is equal to 69. Take the square root, get our friend, take the square root of 69, we get 8.3. X is equal to 8.3. Now that means that's the distance of this length right here. So the entire length of the other diagonal is just multiplied by 2. 8.3 times 2, which is 16.6. Okay, so one of the diagonals, the long diagonal, is 17 feet. The other diagonal we found to just be 16.6 feet. Okay, so we can multiply that now. Now, here's all we have to do is we just have to plug this into a calculator and solve for our area, right? 1/2, and you notice I have my 16.6 right here. 1/2 times that, which could be 0.5 as well, times 17. I'm using that big number because 16.6, I want to use the whole number as much as I can, is equal to 141.2. Okay, so the area of that kite is 141.2 feet squared. Alright, example 4 says a kite has a side length of 7 millimeters and a perimeter of 20 millimeters. If the shorter diagonal has a measure of 4 millimeters, what is the area of the kite? Okay, so the first thing we want to do is we want to draw this whole thing out. Okay, and here let's list out some of the information we know that the perimeter is 20 millimeters. Okay, and if the perimeter is 20 millimeters and one of the side lengths is 7 millimeters, remember that when you know one side length, you know the other side length, right? So this is going to be 7 millimeters. That means this has to be 7 millimeters as well. And the reason why I know the longer end is going to be 7 is because if we double that, 14, that means we only have 6 left to get to 20 millimeters. Okay, so we have, for our perimeter to be 20 millimeters, that means these two have to add up to be 6. And if you cut that in half, that means these have to be 3 millimeters as well. Now we're given a little more information. We're given that the small diagonal is 4 millimeters. Okay, and for the sake of this problem here, I'm going to cut that in half because we know that the longer diagonal splits the shorter diagonal in 2. Okay, so this is going to be 2 millimeters and this is going to be 2 millimeters. So in order to figure out the area, we're missing one more piece of information. We're missing what the distance of this whole long diagonal is. Okay, and the way that we can figure that out is we can use Pythagorean theorem to figure out those last two sides, right? Because we know that 2 squared plus b squared is going to equal 3 squared, and we also know that 2 squared plus b squared is going to equal 7 squared. So let's go ahead and do that. We've got 2 squared plus b squared, we're just going to keep it as b, is equal to 3 squared. And we also know that this formula will give us the length of this. We also know that 2 squared plus b squared will give us 7 squared. That'll give us the rest of the length of that diagonal. Okay, so now all we have to do is solve. 2 squared is 4 plus b squared is equal to 9. Subtract 4 from both sides, and we end up getting b squared is equal to 5. We can take the square root. We get b is equal to the square root of 5. Okay, I'm just going to keep it in radical form for now. Okay, now let's solve this one. We've got 4 plus b squared is equal to 7 squared is 49. Subtract 4 from both sides. We get b squared is equal to 45. Take the square root again, and we get b is equal to the square root of 45. 5. Okay, and again, I'm going to keep it in radical form. Now, we could actually simplify this radical, but let's just keep it like that for now, okay? Now, remember, it says to find the area of the kite, we use the formula, area is equal to 1/2 times one diagonal. Okay, the first diagonal we were already given was 4. And the second diagonal that we're given, we just found it's the sum of both of these, right? It's the sum of this length plus this length. Okay, so we could multiply that then by the square root of 5 plus the square root of 45. All right, now we can just put that into our calculator and solve. We've got 1/2 times 4 times, now in parentheses, remember we have to make sure this is in parentheses, the square root of 5 plus the square root of 45. Now make sure that you are not, it's not the square root of all of that. You got to make sure that they're separated, okay? And we just press enter here, and we get 17.9, okay? 17.9 millimeters squared. And that's the area of this kite.